Hello everyone. Today we're going to be taking a look at stealth aircraft, as well as methods to detect and methods to employ them. So in our particular scenario here, it's pretty straightforward. We're sitting here right in the middle of good old-fashioned Russia. This is just to the east of the Ural Mountains. We're way, way, way up in the latitudes. You can see the curvature of the Earth very clearly in the motion of the aircraft. And what I've done is I've gone ahead and set up a bunch of different types of radars, all basically lined up in a row here, as well as some very, very common, very, very effective slash modern different types of AEW aircraft. So basically what I want to show you today is how stealth kind of can be employed at the same time as what different techniques you can use to prevent stealth from being employed well. So the first thing I'm going to do is I'm going to go ahead and show you kind of a little bit of a Mickey Mouse little demonstration here, just to give you an idea of just how effective some stealth aircraft are, or maybe not effective. So what I'm going to do is I'm going to go ahead and flip on under emissions control here. I'm going to turn on all of my radars. Now keep in mind, I don't just have a couple radars here. I have radars representing every single wavelength a search radar can have, plus modern, plus ancient. So anyway, let's go ahead and unpause. Now the first thing you're going to notice, pause, is the fact that we immediately detect a few targets. Let me go ahead and drag out so you can see this is almost 208 nautical miles away, which is a tremendously long distance. I know your initial instinct is going to be like, aha, you've caught something here. Well, let's see. The other thing I want you to see as well is the fact that although we've acquired a target, its position is very ambiguous. We don't actually know where the target is within this. This is going to matter in a little while, and you'll see why. Now, what I've done in this scenario is I've made it so that if I can identify a target quick enough, I can actually identify what type of target it actually is. So let me go ahead and unpause. So you'll notice I have an F-16, good old CM. We have an F-15, not exactly a stealthy target. B-52, yeah, right. And this guy. You probably recognize that as a J-20. That is a Chinese stealth aircraft. It is a very, very good stealth aircraft. However, for some reason, we're picking it up at a distance of almost 200 nautical miles. Now, you're probably sitting there going, I thought it was supposed to be a stealth aircraft. What's the deal? We'll take a look at that in just a second. Notice what happens when the aircraft rotates. It completely disappears for just that moment. And now that it's pointing directly at us, it vanishes. Oh, there it is again. What are we tracking it by? We're actually tracking it by the Nevo. That doesn't surprise me at all. Now, the reason why it's becoming harder to detect this aircraft is because all aircraft inside of command have different levels of detectability at different angles to the detector. If you actually were to click on something and scroll down here, you can see that from certain angles, it's easier or harder to detect. It makes sense if you think about it. So for example, if I'm looking at the front of this aircraft, I can see it at 3.6 miles, and at 2 nautical miles, I can actually identify it. Now, infrared, obviously, depending on the aircraft, it's easier or harder to see. With infrared, by the way, this is always fun. When you go to the rear, look at how much easier it is to detect. It makes perfect sense if you think about it, because you're looking where the heat comes out of the engines. Now, here's where it gets interesting. This down here gives us a rating of how detectable it is by radar. You'll notice this is split into two bands. One is A to D band, this represents very long wavelengths, and the other one is radar E to M band, which represents much, much shorter wavelengths. The J-20 is sort of a unique aircraft because most of the time it is equally detectable in both sets of bands, where some other aircraft we'll look at in a minute are less detectable in those bands. Now, when our aircraft had turned to the left, it exposed its side, which actually had a bigger, by the way, the negative numbers, the more negative you go, the harder it is to detect. The more positive you go, the easier it are to detect. When it was actually facing to its side, it was easier to detect in that situation. Now, this is going to be a really big deal, especially when we start dealing with F-22s in a minute. So anyway, kind of go ahead and put that away. Let's go ahead and fast forward time here. Pause. So now I've let a little bit of time go. By the way, I should highlight these real quickly so you can see what the different ranges are. So this is about 150 nautical miles. We just detected somebody new. We detected a Su-57 as a Sukhoi. Now you're sitting there going, why did I write the word external? The reason for this is that this particular Sukhoi 57 is carrying some of its munitions on external wingtips. Now keep in mind, a munition hanging off a wingtip, even if it's a Sidewinder missile, can have a greater emission than the rest of the aircraft combined. So you'll notice both the J-20 and the Sukhoi 57, we've actually detected it by its munitions hanging off the wings and not by its physical structure. I'm actually going to scoot over here for a second. You're going to notice my F-35 is also now detectable. You're going to notice my F-22 is also detectable because it's carrying external munitions. Now I'm going to go ahead and speed up time again. Pause. So at 110 nautical miles, we've acquired our next target. We've picked up the F-117 Nighthawk. Now, the F-117, as you probably remember, was one of those stealth aircraft that was supposed to be stealthy, but it got shot down by a system from the 1950s. If you actually look at its emissions, you notice that from the front, it's basically invisible to any radar that's a shorter wavelength. However, from the side against a long wavelength, it's actually pretty detectable. Keep in mind, this aircraft is 100% internal munitions. Let's go ahead and speed up time again. Pause. So our next offender is the F-35. We've detected him at a really spectacular distance of 90 nautical miles. If I were an S-400, by the way, I could engage this aircraft. Keep in mind, those are internal munitions. All right, I did not quite catch that last one. I'm going to go ahead and check it real fast. Let me see. I believe that was this aircraft. So that's the F-22 detected at a range of 76 nautical miles. And I'm going to go ahead and pause. We picked up one last one, and I believe it was this one, the B-2. So let's go ahead and take a look at the emissions of a B-2. Amazing. The B-2 bomber is the most stealthy thing in the air. I know you're sitting there going, isn't the B-2 bomber kind of a big plane? Absolutely, but it is because of its size that makes it stealthier, because of the way that it basically resonates certain specific wavelengths. So anyway, that's basically giving you a rough idea of how easy it is to detect. Keep in mind, I have 1,000 different detectors down here. The other thing I want to point out too is in case you missed it, almost every single time these were detected, the first detector was this APY9. The second detector was the tall rack. These are very, very modern radar systems. So let's go ahead and reset our scenario real quickly. All right, and now let's take a look at a strategy to make stealth better. Now, a lot of people don't believe me when I say this, but the best way to make stealth better is to jam. You're sitting there going, what? Why would you jam? Doesn't that make you more obvious? Not exactly. What's going to happen is you're not going to jam with the stealth aircraft. Instead, you're going to be jamming with somebody else. Because remember, in order to detect an object through jamming, you have to overcome the jamming power. So I have an EA-18 right here, and I'm actually going to flip on its OECM. Watch what happens this time. Keep in mind how many aircraft I have here right now in different radar systems. Go ahead and unpause. Notice we instantaneously detect those 3 aircraft that we saw before, but this is where it gets a little interesting. Pause. Notice my F-35 was detected significantly later than the other one. The other thing I want you to observe is my J-20 is still invisible. You're probably sitting there going, wait, what? Well, take a look. That's why. Because my jamming is not covering the F-35 right now. Stop. So 2 new targets appear. There's the J-20. The J-20 now has gotten far enough away from my jammer that we've actually detected it, even though it's incredibly stealthy. By the way, did you catch the fact the only thing able to detect through jamming was the ANAPY? I hope you did. Pause. We've now picked up the F-35. Again, the reason we picked him up is because he's not being jammed anymore. Scooting over here, of course, you can see that our J-20 is also detectable. All right, we got 2 more. Stop. Looks like we picked up the J-20. We picked up the Sukhoi 57. Aha, who's this? Come on. There it is. Notice the F-117 we didn't detect until we were 60 nautical miles away. Missing somebody? Aha. Bingo. And there's our F-22. So instead of detecting him at a whopping 90 nautical miles, the jamming allowed us to get within, as you can see, 41 nautical miles. Now, as we get closer, of course, you know what's going to happen. These guys are all going to shoot missiles and blow these poor guys out of the air. But that's okay. By the way, notice that we're having a very difficult time acquiring the F-18, even though it's a non-stealth aircraft. Interesting. Okay, so let's go ahead and reset our scenario again. And this time, I'm going to go ahead and delete the aircraft that are detecting. All right, let's get rid of those guys. Again, notice the effectiveness of that APY on the Hawkeye. So let's go ahead and turn on. We're going to leave jamming off for a little demonstration here. Let's go ahead and turn our radars on. And let's let it rip. Notice we still detect them with the Nevo. Pause. Notice the ambiguity with the F-35. We could not engage this F-35 because of the fact that it's in such a ambiguous situation. So notice these targets, even though we're able to detect them, we're not able to detect them precisely. And it is still the Nebo that's doing all the work here. Picked up somebody else. Imagine this is the J-20. Imagine this is the F-35. That's the internal. Where's the F-22? Interesting. Although I believe the F-22 did come up. So what you observe there is the fact that the Nebo is a spectacular radar system. You're sitting there going, what makes it so great? Well, let's take a look at it real quick. Oh, whoa, I faced that the wrong direction. My apologies. Let's see here. Let's get our Nebo here. There's the Nebo. Why is it so effective? Well, the fact of the matter is, look at how tall this is. This is a little guy standing next to it. Look at the size of this. The bigger your radar gets, the more gain you get. So you're talking something that's already probably a megawatt, plus, just to give us what it is, no. Not only is it that powerful, but because of what wavelength it's operating on, which is the B wavelength, we're able to put an enormous amount of megawatts on tower, making it easier to detect the smallest of small items. To make things even worse, of course, because it's so large, it's actually relatively precise. The other thing you've got going for yourself is it works in the B rate wavelength, which means that it's going to have an easier time detecting most stealth aircraft. So hopefully this is making sense so far. Let's go ahead and reset our scenario again. And now let me show you the difference between detecting with the low wavelengths and the high wavelengths. So what I'm going to go ahead and scoot down here. I'm going to delete these aircraft. I'm going to go ahead and get rid of some of our second generation stuff here because this is almost not fair. Notice the MPQ 65 off the Patriot hasn't done anything yet. And let's go ahead and grab all these guys and delete all those. So we're going to concentrate on the short wavelengths. Now, when I say the long wavelengths, rather. Now, when I say that, you're sitting there going, "What are you talking about?" Well, if you've ever looked at a wavelength radar chart, you basically have two major zones simulated. You have what I consider to be the long wavelengths, which are things like UHF and VHF. These are dynamite for detecting long-range targets as well as stealth targets at a cost of not being very range and bearing accurate. And then you have all these radars, which are usually your fire control and missile guidance. These have much shorter wavelengths, but they have a tougher time detecting stealth targets. So what we're going to do is we're going to demonstrate the short wavelength, I should say the long wavelengths, and then we're going to demonstrate the short wavelengths just to see kind of what happens. So what I've done here is a very Mickey Mouse demonstration. We have an A band, a B band, a C band, and a D band. Now in this program, let's go ahead and grab the database real quickly. Let's go ahead and type in, we'll grab an F-117. These are always fun. Yes, I know that's the C version. Check it out. From the A to the D band, this is how detectable it is. From the E to the M band, look at how detectable it is. So let's try just A to D with our actual radars here. So I'm going to grab these guys, group them together. I'm going to go ahead and say, everybody turn your stuff on. Let's just double check to make sure that worked correctly. Yep, it worked good. Okay. So now watch this. Stop. Notice we were able to acquire our F-16, our B-52, and our F-15 almost immediately. One thing I want to point out, though, is notice who acquired. First of all, our A-band, and it looks like we have a P-40 that's an E-band, but that's long enough wavelength. Stop. What just happened? You'll notice now that some time has passed, and we were able to acquire all of the external ordnance aircraft at a distance of 110 nautical miles, still with that ancient A-band radar. We've just detected the Sukhoi 57, and I believe we just picked up the F-117. Yes, an F-117 is detectable at a range of 60 nautical miles with a radar that's ancient. Just kind of keep that in mind. Actually, it looks like the C-band radar did the job here, but that's okay. And it looks like we've got everybody. We do. And that's at about 33 nautical miles. So let's do the exact same scenario, but this time what I'm going to do is I'm going to only use the short wavelengths. All right, let's go ahead and get rid of our AWACS aircraft. All right, who is our short? So F and G, we'll do I, J. That'll work perfectly for me. So these are kind of your Shorter wavelengths. Radar on. Shorter wavelengths are usually associated with significantly less range. Like you'll notice in this scenario, the longest we can see with those short wavelengths is about 40 nautical miles. We can't even detect anybody all the way out there. So it's kind of interesting how those kind of act. Basically, your long wavelengths are for detecting enemies at early, and then your short wavelengths are for prosecuting. Now observe what happens when they get into range. I'm actually going to turn on God mode. Notice every single one of these aircraft is in range now, but they're completely undetectable. Who's the first victim? I expect the B-52. Oh, it was the F-15. Figures. The B-52 hasn't got here yet. F-16? Yep. Keep in mind, look at this range. That's 22 nautical miles. That's cruise missile range. Can't use Maverick, though. We still have not detected any of the stealth aircraft. Look at where they are. I have no problem detecting these guys. Oh, got somebody. Who's this? There's our F-22. Notice the F-22 got picked up early. Now, if I actually go here and take a look at radars with short wavelengths, you'll see that the F-22 is actually not the greatest for that. There's another point I want to throw out, and that's the fact that if you actually look at this from the side, if you're only about, let's say here, 10 nautical miles away, and you're only 6 nautical miles up, if you want to imagine this is up and this is out, your F-22 is actually here relative to our radar. So we're looking at the bottom instead of the front. So as a result, if I wait 2 seconds here, you'll see that all of our external guys start to get detected immediately. Did you notice, by the way, the B2 has still not been detected? B2 is right there, I think. Yep, watch this. Our Sukhoi 57. Notice the external Sukhoi 57. And everybody else flew over the top and was never, ever detected. So hopefully this is a really powerful demonstration. Now the cool thing here is even though I can detect these stealth aircraft with my long-range radars, I can't engage them with my more accurate shorter wavelength radars. So it's really critical that when you're planning these kinds of operations, you keep these things in mind as you do them. All right, one last demonstration. Again, this is more just to give you a kind of a way to look at problems. So I'm going to go ahead and grab our aircraft, and this time we're going to take a look at some of our specialist radars. So I'm actually going to delete all these guys because I don't need them. Let's delete there. So we've already talked about the Nebo. This thing's epically good at detecting stealth aircraft. Let's take a look at some other options. The MPQ-65, as you probably know, is the radar that you see on Patriot batteries. This is a combination detection as well as engagement radar. We have the this guy, which you probably recognize. That's the big terrifying S400 SAM radar detector. It's the cheese board. We have this one right here. This is a YLC4. This is an excellent anti-stealth radar. And again, take a look what wavelength it's operating on. Surprise, nice and long. And then last but not least, we have an over-the-horizon coastal defense radar, which unfortunately we don't need the other half of this. But what I do want to do real quickly is just to demonstrate how this works. Actually, does this one even detect air targets? Yes, yes, indeed it does. So this one has an ultra long wavelength. It's actually kind of cool. So I'm going to go ahead and, is this one of those that we can do that with? No, I just have to trust that I'm going to do it correctly. It's going to be about there, I think. Let's go ahead and turn himself on. Oh, close enough, close enough, close enough. Check this out. Look at the range on this radar. 242 miles. Now, keep in mind, this radar, as you can see from this picture right here, is, oop, wrong one, is huge. Look at how tiny that little building is. So it has the ability so well that it can actually look over the horizon to see targets. But now watch what happens against our beautiful stealth targets here. Look at how ambiguous they are because of the fact that the wavelength is so big, we can't actually measure precisely. There's our stealth buddies. Notice we pick up the external ones first. And we never, ever, ever detect the internal ones. So even though you have a super long wavelength, you have to have the processing and the power behind it to actually make it useful. So let's go ahead and take a look at Airborne Radar. As you guys probably know, the Airborne Radars are the champions of anti-stealth because they have so much range, and they also tend to have amazing processing power and stuff along those lines. So what I'm going to do really, really quickly here is I'm going to go ahead and delete everybody, except for a handy dandy mainstay A. Flip that on, and we're going to watch the same demonstration again. Notice, as usual, we picked up the J20 at a distance of about 110. Picked up, I think this is all external still. Stop. And then we finally pick up the dangerous ones like your F-22s and F-35s and stuff like that. Is this an F-35? Yeah, but that's an external F-35. Now we pick up the F-117. But notice the B-2 is always the last to be detected because it's so big. It just distributes the wavelength so effectively. Okay, hopefully that helps you a little bit kind of understand how stealth works and how to kind of counteract it. Keep in mind an opponent that has some sort of infrared detection system will still be able to pick up your stealth aircraft, especially from behind. Enjoy.